Hey everyone, welcome back. Today we're going to be talking about the distance formula and how to use it. Let's get started. First, let's talk about the formula. We use the distance formula a lot of times to find the distance between 2 points. So the way the formula is written is we have a lowercase d. Inside parentheses we have the 2 points that we're trying to find the distance between. And we set that equal to the square root of x2 minus x1. And we square those, and then we add y2 minus y1 squared. Okay, so let's go ahead and let's jump straight into how do we use this formula to solve some popular questions. A lot of times problems will look like this. So for this first problem, we see that PQ has the endpoints of P -5, 4 and Q 7, -5, and it wants to know what is the length of PQ. So the first thing we're going to do is we're going to go ahead and write out our distance formula. So we want to know the distance between P and Q. And that's going to equal the square root of x2 minus x1 squared plus y2 minus y1 also squared. Next thing I like to do is I like to label my points. So let's go ahead and label P. P would be x1 and y1. And then Q would be x2 and y2. And now we're going to go ahead and we're going to plug those in. So I'm going to get this equal to the square root. I'm going to have x2, which is 7, minus -5. We're going to go ahead and we're going to square that. Plus y2, which is -5, minus our y1, which is 4. And we're going to go ahead and we're going to square that as well. Now it's a matter of working out our additions and subtractions that are inside of the formula, so we're going to go ahead and do 7 minus -5, which double negative, that's going to turn into a positive, so that'll actually give me 12 squared. Plus a -5 and a -4, combining those, you get a -9, which is also going to be squared. So 12 squared would be 144, plus a -9 squared would give me an 81. Together, those two combine to the square root of 225, which is simply 15. So this is one way to use the distance formula, and it's actually pretty common for them to ask a question like this. Now, the other type of question that I'm going to show you today has to do more with applying it to a word problem. So let's go ahead and let's check that out. This word problem is about a pitcher who throws a ball, and we're trying to map out how far did this ball actually travel. So let's go ahead and let's read this word problem. It says a pitcher throws a ball to a batter who hits the ball to the shortstop. If the ball travels in a straight line between each, what is the total distance the ball traveled? And it wants us to round our answer to the nearest tenth of a foot. So, first thing I like to do is go ahead and reread the question and try to map out the distance traveled by the ball. So it says a pitcher throws the ball to a batter. So the ball went from the pitcher to the batter. And I'm going to go ahead and mark those points. So I see here that the pitcher is standing at 5, 5. And the batter is standing at the origin, which is 0, 0. Okay. Then the ball went ahead, the batter hit the ball and hit it towards the shortstop. So the shortstop is standing at the point 5, 10. Okay. So now let's go ahead. Once more, I'm going to go ahead and rewrite the distance formula. So we were looking for the distance between 2 points, Q and P. It's going to equal the square root of x2 minus x1 squared plus y2 minus y1 squared. All right. So now I am going to go ahead and we're going to use the distance formula twice in this scenario. Once to find the distance that it went between the pitcher and the batter, and then from the batter to the shortstop. So I'm going to go ahead and write my first 2 points. I'm going to say point P for pitcher is at 5, 5, and point B for batter is at 0, 0. Let's go ahead and label these. I'm going to say pitcher is the first point, so I'm going to say x1, y1, and the batter will be x2, y2. Okay, so let's go ahead and plug in these first set of points. We are looking for the distance between the pitcher and the batter. It's going to equal, if I plug these points in, I'm going to get that x2 is 0 minus 5, which is x1, and we're going to do that squared. And you're going to see that the y values are actually exactly the same as well. y2 is going to be 0 minus y1, which is also 5. We're going to head and square that. So, working this out, I get the square root of a -5 squared plus another -5 squared, which gets me a 25 plus a 25, which is simply 50. Square root of 50. We're going to go ahead and calculate these and round them in the end. For now, let's go ahead and solve our other distance. So from the batter to the shortstop, again, based on the diagram, my batter's distance does not change, so my batter's still going to be at, I'm sorry if I covered the formula, just notice that. The batter is standing at point 0, 0, and the shortstop is standing at point 5, 10. So shortstop is at 5, 10. So now we're going to use the distance formula to find the distance between the batter and the shortstop. Again, I'm actually going to label my points first. So the batter is at x1, y1 now, and the shortstop is now x2, y2. So let's go ahead and let's plug these into the formula. We want the square root of x2, which is 5, minus x1, which is 0. And we're going to square that. And then we're going to add y2, which is 10, minus our y1, which is 0. We're also going to square that. So, doing a little bit of math, adding, subtracting, 5 minus 0 is 5 squared, plus 10 minus 0 squared, which is 10 squared. This would get us the square root of 25 plus 100, which give me the square root of 125. So now, if I want to find the total distance that this ball traveled, I want to find the total distance, I would add up those two distances that I just discovered. So the square root of 50 plus the square root of 125. If I calculate those correctly and if I do my math and round to the nearest tenth, you should get 18.3 feet. Alright, so hopefully that was helpful. Hopefully you do understand all the work that we did here. And again, sorry if I covered the distance formula at one point, but you should have been able to reference it at an earlier point. So I hope these two examples on how to solve problems using the distance formula or questions that ask about the distance formula have given you some insight on how to use it. And hopefully if you have questions, you'll feel free to ask them, and hopefully I can get back to you in time. But if not, this is the end of this video. Thanks again for watching, and hopefully you see me again in some other videos.